In this video I am going to do 7 graphs with calculus. Because I already know the general shapes, I'm going to graph them by deciding where they're flat, which is how calculus helps. The first one is a cubic, therefore I know it already has a snake shape like this or like this. That is already ready for calculus, so I can do the second row of the multiple choice box straight away. If I want to know where it's flat, then I put a 0 there. If you solve that by factorising, you get 2 places where it's flat. You get x equals 1 and x equals 2. Now I'm going to decide how high it is when it's flat. So if x equals 1, to decide how high it is, I'm going to put a 1 everywhere there. So it's a third. Take away 3 over 2 plus 2. So that's 5/6. And if x equals 2, it's 1 over 3 times 8 minus 3 over 2 times 4 plus 4. And there's never any excuse for not doing the y-intercept, so put x equals 0 in the top row and you get y equals 0, so it goes through there. It's flat at 1,5/6, so let's make that 1, and, or actually let's not, let's make that 1, so 5/6 would be about there. 2, 2/3 will be about there, so it's flat twice and has a y-intercept there. So that's the graph. And there it is. Question number 2. This is Aquatic. So it has it's kind of like a kinked bucket. So that general shape. Here's the multiple choice box. Where is that flat? So it's flat if x equals 0, if x equals -1 or x equals 1. How high is it when it's flat? If x equals 0, then y equals 0. If x equals -1, then it's 1/4 minus 1/2, which is -1/4. And if x equals 1, then it's 1/4 minus 1/2 as well, which is -1/4. So the graph is and the y-intercept, if you put x equals 0 in there, you get y equals 0. So the y-intercept is there, and I said it was flat at x equals 0, y equals 0, so it's flat there. It's also flat at 1, -1/4, and at -1, -1/4. So here's the graph. It's only because I knew that the shape was a kinked bucket that I can graph it so quickly simply by knowing where it's flat and knowing where the y-intercept is. You should label the key coordinates. Okay, so that's number 2 done. Number 3. This is an unkinked basic bucket, in other words a parabola. It's ready for calculus. So, where's that flat? It's flat at x equals 2. How high is it when it's flat? If x equals 2, you get 4 minus 8. It's negative 4 plus 5 is 1. So it's flat at 2, 1. And it has a y-intercept of 5. Which I haven't made very neat here. And that's your graph. Question number 4, another cubic. That's ready for calculus, so the box can be done straight away. To find where it's flat, put a 0 where dy dx is. Solve that by factorising. So it's flat at x equals 3 and x equals negative 1. How high is it when it's flat? This one need to count. Oh, maybe not. If x equals 3, that's 27, so that's a 9. So 9 minus 9 is 0, take away 9 is negative 9. Negative 1 shouldn't be too hard to sub in. Negative 1 cubed is negative 1, so that's negative a third. Minus 1, that's negative 1 and a third. Plus 3, negative 1 and a third plus 3 is 1 and 2/3. And the y-intercept is 0. If you put a 0 where x is there, you get y equals 0. So here's the graph. There's the y-intercept. It's flat 3 across.
Where is she? Yeah. How do we go? Do you want me to open it for you? How do you do that? Am I allowed to be opening these? Yeah.
So it's flat there. And it's also flat
In the bin. Oh, no, it's okay.
at
In the bin. Here's the bin.
right about there. And there's the y-intercept there, so there's the graph.
You ran away from Mommy with Scarlett. Good work. Give me 5.
Label the coordinates.
I thought they were there all of a sudden. They were like, are you not here? The mock papers are everywhere.
They got me to open their chocolate ice, and that's okay.
Okay, so that's that graph.
Yeah, did you say thank you, Scarlett?
She did.
Yeah, sounds a little like she's but I don't think she is. She might be. Scarlett, stop running.
Okay, next question is this one. This is another snake graph. Solve that. Oh, sorry, that's an x. Solve that by, so put a 0 where dy dx is, solve it by factorising. I'm going to times everything by negative 1. So where is it flat? It's flat at x equals negative 3, x equals 2. How high is it when it's flat? Is someone use a calculator for? 6 times negative 3 minus half times negative 3 squared minus a third times negative 3 cubed equals negative 13.5. If x equals 2, that should be easy to work out in my head. If x equals 2, that's 12. That'll be a 4, so altogether this is 2, so 12 take away 2 is 10. Take away 2 2/3 is 7 1/3. The y-intercept is 0 again. So here is the graph. That's the y-intercept. I said it was flat at negative 3 all the way down so 7 1/3 is up there, it's flat there. Negative 3, negative 13.5. It's also flat there. So that's the graph. And of course label the coordinates. There you go, that's that graph done. Graph number 6. Here's another cubic. It's ready for calculus. Find out where it's flat by putting a 0 where dy dx is.
Sophia, come down here. People are trying to work. Come down here. I won't tell you again. Come down here now.
Solve it by factorizing. Find out how high it is when it's flat. This I'll definitely need a calculator for. So 2/3 times negative half cubed plus 3/2 negative 1 squared so 11/12, whereas if x equals -1, it's negative 2/3 plus 3/2 plus -1, which is -1/6, and the y-intercept is 0 again. So here's the graph. Okay, so it crosses at 0,0. So it's flat. So negative half comma 11/12, it's flat there. And negative half comma 11/12, it's flat there. Negative 1. So negative half comma 11/12, it's flat there. Negative 1 comma negative 6, that's flat there. So it goes like this, and there's the y-intercept. So 0,0 is the y-intercept, negative half comma 11/12, it's one flat point, and negative 1 comma negative 1/6 is another flat point. So that's that graph. And finally, here's a bucket shape. Where's that flat? X equals 1. How high is it when it's flat? If you put a 1 in there, you get negative 1 plus 2 is 1, take away 1 is negative 1. Its y-intercept is negative 2. That comes from putting a 0 in there. So the y-intercept is negative 2, and it's flat at 1 comma negative 1. So there's the graph there. There we go, that's finished.